What's up, Patriots? So this is a follow-up video to the last one I made about completing the square. So we had done the first page, which kind of took us step by step through the process of completing the square, and then now we're going to take that skill and apply it to 8 different quadratic equations. Now about half of them I'm going to model for you, and then the other half are U-tries. And so I probably won't be doing those ones just because the video will get super long. But you can find the keys, the answer to the U-tries on your teacher's webpage. They probably have an answer key. All right. So let's look at this first example. Our equation is x squared plus negative 2x equals 3. Okay. Now I am probably going to be writing super big, and so I'm just going to use a separate sheet of paper to work out this equation. Okay, so x squared. Now I can write it as plus negative 2x. I'm just going to choose to write it as minus 2x equals 3. Okay. All right, so if we look at our steps, right, steps 1 and 2 can be interchanged. So divide to make the coefficient of x squared 1. It's already 1, so that's taken care of. And then isolate the constant. The constant is already by itself in the right expression, so that's already taken care of as well. Okay. So we're just going to dive right into completing the square. And the way I showed you in the first video was to use the area model, and I'm going to repeat that process again. Okay. So we're going to make an area model, okay, to represent the expression on the left. Okay. So our second degree term, okay, its place is in the top left. Okay, our first degree terms will be split equally among these 2 diagonal boxes. So if you divide that by 2, you're going to have negative 1x in that box and negative 1x in that box. Okay, so all I've done is I've taken the expression here, x squared minus 2x, and represented it in a box, x squared minus 2x. Now the expression on the right is also going to get represented in a box of the same size, right? Equal means the same. And it has to take up the same sort of space, right? So what these 3 terms take up in this area model, the 3 has to take up the same region. Okay, so that kind of, I don't know, L-shaped block. So now we're going to kind of prematurely start factoring, okay, because we still haven't figured out what this 4th box is. Okay, so x squared would require dimensions of x and x, okay, and then negative 1x would require 1 dimension of x, and then the other dimension would be negative 1. Same thing could be said here, right? X times negative 1 makes this product, and then now we can figure out what that missing box is, and we will complete the square. Okay, so negative 1 times negative 1 is positive 1, right? So we're going to put a positive 1 here to complete that square, and we'll put a positive 1 there to complete that square. Okay, so the area model on the left, we're now going to represent it using its factors, x minus 1 by x minus 1. And the area model on the right will just represent it as the sum of the 2 regions. 3 plus 1 is 4. All right. We have repeated multiplication here, so we're going to write that as an exponent. Okay. X minus 1 squared is equal to 4. And now we're going to start using inverse operations to get the variable x by itself. Okay, so we'll take the square root on both sides. Square roots reverse squaring. So that's going to be x minus 1. And don't forget about this part. When you take the square root of a number, there's a positive version and a negative version of the square root. Okay. So 4 is actually a perfect square. So the first square root that would come to mind is positive 2, but also negative 2 is a square root of 4 as well. So we'll write it as we'll write it as plus or minus 2. All right, let's break this into 2 separate equations. Right, so x minus 1 is equal to positive 2, and then x minus 1 is equal to -2. Okay, and then we'll just solve. Add 1 to both sides of that equation. Add 1 to both sides of that equation. Okay. Now, because 4 is a perfect square, its square root is an integer, so everything here is an integer, right? Which is really, really good. So this is going to be x equals 3. And this equation will have a solution of x equals -1. Okay. All right. So that was a lot easier than the first one we did. Just trying to zoom out so you can see the whole process. Okay. So the square term already had a coefficient of 1, and the constant was already isolated. So we dived right into the area model so we could complete the square. Okay. And then we factored the area model on the left, took square roots, and then just kind of, these are just one-step, sometimes two-step equations. And so there you go. All right, so I think I'll end this video and just make a separate video for the next problem. Don't forget, you can check your answer using Desmos or use Mr. Weinert's tool.